Exactly. And whether you are, prepping for a major corporate meeting or trying to run your own startup team, or you're just insanely curious about how the world actually works, understanding the mechanics of a smoothly running system is just an absolute superpower.
It really is.
So, for this deep dive, we are getting into the exact blueprint of a perfectly tuned organization. We're looking at a really fascinating guide today.
Yeah, we are. It's called Operational Excellence, a concise guide to basic concepts and their application. It's by Gila Desar and Liat Ramadi Navan.
And our mission here is to just extract the absolute best nuggets from their work.
There's a lot of good stuff in there.
Oh, yeah. We are going to decode how you can mathematically predict failures before they happen, how to balance the financial realities of a massive business, and explore why making sure a brand new hire doesn't eat lunch alone might be just as critical as your multi-million-dollar software systems.
Yeah, that lunch thing is so important.
But, okay, let's unpack the core concept first. Operational excellence, or OpEx. I mean, this isn't just a corporate buzzword here.
Definitely not. No. Isar and Navan define OpEx as the complete unification of finance, HR, engineering, and supply chain. Bringing it all into one single lean system.
Okay.
It's the shift from a company just operating at a good level to a truly excellent one.
Right.
And to initiate that shift, you have to secure the absolute heartbeat of the operation, which is assurance of supply, or AOS.
So AOS basically asks the fundamental question, right?
Yeah.
Are you actually giving the customer the thing they paid for when they expect it?
Exactly. And if an operation fails at assurance of supply, I mean, nothing else matters.
Yeah.
You could have incredible marketing, brilliant R&D, a great company culture,
Sure.
but it all becomes entirely irrelevant if you can't physically deliver the product. So AOS has to be embedded into the very DNA of an organization's culture.
Right. It's like the ultimate baseline.
Exactly. It has to dictate the daily schedules, the self-measurements, the plans. Every single team member's top priority should be the overall team goal of meeting that output.
But, I mean, in the real world, things break.
Right.
Machines go down, a supplier gets stuck at a port, someone enters a typo in a database.
Oh, it's constantly.
So how do you guarantee that supply when reality is so unpredictable?
Well, the guide outlines a very pragmatic way to build an inventory safety net.
Right.
And it's not based on guesswork. It's based entirely on your historical recovery time.
Okay, so let's walk through that.
Sure. So let's say your historical data shows that an average catastrophic production stop, like maybe a critical stamping machine, completely breaks down, takes 4 weeks to fix.
Okay, but if a machine takes 4 weeks to fix, you don't just hold 4 weeks of parts, because you have to account for the time it takes to restart the engine.
Right, exactly.
So if the repair takes 4 weeks, you need an extra week to get raw materials moving back in from your suppliers.
Yep.
And then another week to get the finished goods onto trucks and out to customers.
Yeah.
So 4 weeks of repair means you actually need 6 weeks of buffer.
Bingo. That mathematically calculated red line of minimum safe inventory is what prevents a localized disaster from becoming a total customer failure.
That makes a lot of sense.
And to monitor those safety levels, organizations rely on decision support systems, or DSS.
Those are basically the dashboards, right? The tools measuring key performance indicators.
Exactly. And the guide sets 3 strict criteria for any DSS: importance, accuracy, and usage.
Okay, let's unpack this. That second one, accuracy, is where we really need to pause. Because I always assumed an accurate dashboard just meant, the database was correctly pulling the numbers and the math was right.
A lot of people think that.
But the definition here is way harsher. If a system only reveals a crisis after it happens, it's considered inaccurate.
Exactly. It has to be proactive.
It's exactly like a smoke detector. If your smoke detector only goes off when the house is already just a pile of ashes, it's completely useless. I mean, it's technically measuring the fire, but it failed its entire purpose.
That's a great way to look at it. The DSS absolutely has to be predictive, and that ties directly into the third criteria, which is usage.
Right.
Because you can have a highly accurate predictive dashboard, but if it requires navigating through, 6 different submenus and nobody checks it during their daily routine, the organization will still burn.
Yeah, it's just hidden away.
Data has to be front and center.
But wait, let's go back to that 6-week inventory buffer. I have to push back a little here.
Sure.
Isn't safe inventory just a fancy corporate phrase for hoarding parts just in case? I thought modern business was all about being lean, not having warehouses full of cash, just gathering dust on a shelf.
What's fascinating here is that you're hitting on the core tension of operations. Inventory is indeed cash tied up on a shelf, But that 6-week buffer isn't arbitrary hoarding. It's a calculated insurance policy based on historical reality.
Okay.
You are constantly balancing the hoarding of inventory against the risk of starving the system. And this connects directly to the concept of burst capacity or overcapacity.
So let me think this through. If the buffer is 6 weeks, burst capacity sounds like we need the ability to sprint.
Yes.
Like designing the production line to run at 110% capacity for a short period to rapidly refill that buffer once a crisis is over and the buffer gets depleted.
You've got it. Overcapacity isn't an accident or a waste. It is a designed, proactive strategy.
Oh, wow.
Yeah, if you have that burst capacity, you can catch up much faster when things go wrong. And over time, as your recovery gets faster and your systems get more stable, you can safely shrink that inventory buffer down from 6 weeks to 5 or 4.
Right. But having a buffer and the ability to sprint doesn't actually stop the machines from breaking in the first place.
No, it doesn't.
If we want to safely shrink that buffer and free up that cash, we need to stop reacting to fires and start preventing them entirely.
Exactly. And that requires predicting the future mathematically.
Which sounds impossible.
It does, but the primary tool for this is FMEA, failure mode and effect analysis. It's basically a systematic way of scoring potential failures to prioritize your engineering efforts.
The formula for this is brilliant. You multiply severity by occurrence by detectability to get a risk priority number, or RPN.
Right.
Let's make this concrete. Say we run an automotive factory. We have 2 risks we are worried about. Risk A is the main assembly conveyor belt snapping.
Okay.
The severity is massive, like a 10 out of 10, because production stops entirely. But it happens maybe once a year, so occurrence is a 5.
Sure.
But detectability, if the belt snaps, we know immediately. The chance of a broken belt somehow sneaking past us to the customer is really low, maybe a 2. So 10 times 5 times 2 gives us an RPN of 100.
Perfect. Now consider risk B. Let's say it's a slightly off-spec batch of engine screws from a supplier.
Okay.
The severity of a single bad screw might seem lower, maybe a 6, but the occurrence is high, maybe an 8, because this specific supplier has a pretty spotty record.
Right.
But the detectability is the real danger here. A slightly weak screw might look totally fine on the assembly line, but it snaps 3 months after the customer buys the car.
Oh, man. Yeah.
So the detectability risk, meaning the risk of not catching it before it leaves the factory, is a 9. So 6 times 8 times 9 gives an RPN of 432.
Wow. So instead of spending your engineering budget reinforcing a conveyor belt that rarely breaks and is obvious when it does, you spend it aggressively auditing the screw supplier.
Exactly.
It mathematically scores your paranoia. You stop lying awake at night worrying about everything equally.
Yeah, it takes the emotion out of it. And once you've mitigated those high-scoring risks, you still have to manage the physical flow of the work itself.
Right.
This is where the theory of constraints comes in, specifically a concept called drum, buffer, rope, because every system has a constraint, a slowest point.
And the constraint dictates the drumbeat, right? Like the absolute maximum pace your entire production line can move.
Exactly. Then you have the buffer. This is the specific amount of work in process you keep parked right in front of that constraint, ensuring the slowest machine or person never, ever has to stop and wait for parts.
Got it.
And finally, you have the rope. This ties the release of new raw materials at the very beginning of your production line strictly to the exact pace of the drum.
Here's where it gets really interesting, because this makes complete sense if you picture a crowded nightclub.
Oh, I like this.
Think of the bouncer at the front door as the rope. The bouncer only lets people into the club as fast as the bartender, who is the bottleneck, right? The drum can actually serve them drinks.
Yeah.
If the bouncer just lets everyone in at once, the club is flooded. People are crammed together. Nobody is getting drinks. It's total chaos. That represents excess inventory waste on a factory floor.
That's a spot-on analogy. Because flooding the constraint creates massive waste. And if that bouncer is too strict and doesn't let enough people in, well, the bartender's just standing around wiping down empty counters doing nothing.
Right, which is just as bad.
It is, because that's starving the system. It causes an assurance of supply failure because you aren't producing. The buffer is just that short, manageable line of people standing right at the bar, ensuring the bartender is constantly pouring, but the room itself isn't a disaster zone.
And Isser and Navon actually documented this exact methodology working in the real world. They highlight an organization that implemented drum buffer rope and managed to reduce their overall inventory from 120 days down to just 60 days within a single year.
That is huge.
They cut the inventory sitting on their shelves in half just by perfectly timing the bouncer to the bartender.
Which is a monumental achievement. because, as we established earlier, reducing inventory frees up cash.
But, optimizing the bartender and the bouncer isn't just about keeping the nightclub floor clean. It's about whether the club can actually pay its rent.
Right.
All of this physical flow has to translate directly into financial survival, which means we have to look at gross margin.
Gross margin is the ultimate indicator tying your physical operations to business reality. When you reduce that inventory from 120 days to 60 days, when you improve your drumbeat, you are improving gross margin.
And improving GM brings cash straight to the bottom line.
Exactly. And to improve that gross margin, you have to attack your cost of goods, your COGS.
Right.
The guide applies the Pareto rule, the 80-20 rule, to the bill of materials. It strongly advises against wasting time trying to save pennies on every single tiny part. You have to focus your cost reduction projects strictly on the top 20% most expensive items.
Because the math behind this is critical for manufacturing. Usually 80% of your total material costs are tied up in just 20% of the components.
Yeah.
So if you spend months negotiating a 50% discount on, rubber floor mats, it barely moves the needle. But if your engineers can find a way to save just 1% on the vital engine block, the cash savings are enormous.
Exactly. You focus your procurement energy where the financial leverage actually exists.
Okay, so that handles the physical parts, but what about the internal waste? Like the cost of the production overhead itself?
Well, they outline a really great practice called a start, stop, continue session.
I love this one.
It's a structured meeting where a team decides, what new habits do we need to start? What good processes should we continue? And critically, what redundant activities must we stop doing immediately to lower our overhead?
It's so simple, but so effective. And to manage all this data, the bill of materials, the inventory, the flow, the costs, massive organizations use enterprise resource planning or ERP systems.
Right. It acts as the central nervous system.
But there's a massive trap here.
Oh, huge.
The authors explicitly warn against customizing the ERP software to fit a company's old habits. They insist companies must use the built-in best practice processes that come with the software out of the box.
This raises an important question, though, right?
Yeah, because I really struggle with this advice at first. Usually, in business, a premium solution is tailored to your unique needs. You want a custom-tailored suit, not something off the rack.
Right.
Why on earth would you spend millions on enterprise software and just use the generic off-the-rack settings?
Because it's the most common mistake in enterprise tech. If you spend millions customizing the software to perfectly fit the way you work today, you are almost certainly taking state-of-the-art technology and mapping it directly onto your old, inefficient processes.
Oh, wow.
Yeah, you are literally paying millions to hard-code your bad habits into a new database.
That totally reframes it. So by adopting the standard best practices built into the ERP, the software actually forces the organization to evolve.
Yes. It's the catalyst.
It forces you to shed those redundant activities we just talked about stopping and aligns the whole company with industry standards.
Exactly. It drives the operational excellence we're aiming for.
It's brilliant, but it brings up a glaring vulnerability. None of these mathematical systems, not the standard ERP processes, not the FAMEA paranoia score, not the drum buffer rope nightclub, none of it matters if the human beings running them are miserable or disconnected.
That is so true.
How do we manage the human engine to actually achieve this excellence?
Well, there has to be a fundamental shift in HR philosophy. In modern operations, people are not just physical output mechanisms like gears in a machine.
Right.
The guide argues that soft skills, things like active listening, empathy, and honesty, are actually the new required technical skills for managers.
It's a huge departure from the old command and control factory floor mentality.
Absolutely.
And it begins the moment someone walks through the door. They emphasize diversity because diverse perspectives drive innovation. But the new higher orientation, the NHO, has this surprisingly human focus.
Yeah, this part is great.
Out of their 10 focus points, they talk about assigning a tutor, implementing shadowing, and making absolutely sure the new employee does not eat lunch alone their first week.
It seems like such a trivial HR detail, doesn't it?
Yeah.
But the psychology is foundational.
How so?
Because operational excellence relies entirely on trust, communication, and psychological safety. You need employees who feel secure enough to point out dangerous errors or suggest process innovations.
Right.
If a new hire feels isolated, ignored, or invisible in week one, you suppress their potential to ever contribute to that culture.
Yeah, if they're eating lunch alone in their car every day, they aren't going to be the ones who raise their hand next month to say, hey, I noticed this assembly step is totally redundant.
Exactly. And those small observations matter. The authors point out that even a tiny 1% innovation saving found on the operations floor multiplies. It flows all the way through to the massive total budget.
So to give employees the mental space to actually spot that 1% saving, managers have to fiercely protect their time.
They do. And the authors apply lean principles directly to communication using Stephen Covey's matrix of urgency and importance.
Now, Covey's matrix is a concept we're all pretty familiar with, right? Categorizing tasks by what's urgent and what's important.
Right.
But applying it strictly as an operational health metric is what's so interesting here. Having an inbox full of urgent emails isn't a badge of honor for a manager. It's a symptom of highly unstable infrastructure.
Exactly. If everything is an emergency, you don't have a robust system. You have a constant state of crisis management.
Yeah.
So the advice is to mercilessly delete the non-important, non-urgent noise. You obviously handle the urgent and important crises, but the real secret is dedicating heavy focus to the emails and tasks that fall into the important but not urgent quadrant.
So what does this all mean? It's exactly like changing the oil in your car.
Right?
Changing your oil is incredibly important, but it is never, ever an emergency on a random Tuesday morning. You can always put it off.
Until you can't.
Exactly. Until you ignore it for 15,000 miles and your engine completely seizes up on the highway on a Friday afternoon, suddenly it is the most urgent thing in the world. Handling the important but not urgent tasks is how you proactively prevent the next crisis.
That's a perfect way to put it. Empowering employees, building trust from day one, and clearing out that urgent but unimportant noise gives everyone the actual space to do strategic thinking.
Yeah.
The ultimate sign that an organization has achieved true operational excellence isn't people running around frantically solving massive problems. It's a surprisingly quiet email inbox.
Oh, wow.
Because the crises are being solved by the system before they ever become fires.
We've covered a massive amount of ground today. But the true beauty of this blueprint is that these concepts scale perfectly. Whether you are managing a global supply chain for a tech giant, running a small startup team, or honestly, just trying to organize your own personal life.
They really do. The underlying principles of flow, constraint management, and risk mitigation remain exactly the same regardless of the size of the operation.
I mean, you can sit down tonight and run a start, stop, continue session for your own daily habits.
Absolutely.
You can calculate a personal RPN score to figure out what your biggest actual risks are this coming month, rather than just worrying about everything equally. And you can start tackling those important but not urgent tasks to clear the chaos out of your future schedule.
It is all about shifting from a reactive state to a deliberately proactive state.
Exactly. So we want to leave you with a specific thought to mull over as you go about the rest of your day.
Yeah.
Take a hard look at your own daily life and ask yourself, what is your personal drumbeat? What is the single ultimate constraint holding back your daily output?
Right.
And more importantly, are you accidentally flooding that bouncer with endless distractions?
Right.
Or are you starving your bartender of the focus and resources they actually need to thrive? Think about how you can build your own personal buffer to keep your life flowing smoothly. We're going to focus strictly on the mechanics of prioritizing cost reduction, mathematically improving gross margins, and doing something that sounds almost paradoxical,
Which is?
fostering genuine disruptive innovation within operations teams, which historically, I mean, that's a department most people associate with strict compliance, not innovation.
Right. Definitely not the creative types usually. So, okay, we're going to bypass the dry corporate jargon. We're going to look under the hood and see how supply chain optimization and manufacturing overhead are actually the levers you pull to build an unstoppable business.
Let's do it.
Let's start with the big picture, the what and the why. Why has operational excellence shifted from being, a nice to have efficiency metric to an absolute survival requirement in the last decade?
Well, the global landscape has just fundamentally structurally changed.
Yeah.
We're no longer building products entirely in one city or even one country.
Right. Everything is everywhere.
Exactly. You have this massive, complex, worldwide spread of supply chains.
Mm.
A single consumer electronic device might have components sourced from 30 different countries.
Wow. 30.
Yeah, and at the same time, product life cycles are drastically compressing. It used to be that you could design a product, release it, and milk the profits for 5 years.
And now?
Now, a product might only be relevant in the market for 9 to 12 months before the consumer demands the next iteration.
Wow. So the margin for error has essentially vanished. I mean, if your product life cycle is only 9 months and your supply chain gets delayed by 3 months because of a sourcing issue,
You've just lost a third of your total revenue window.
that is wild.
It's exactly the problem. The competition is so intense that if you stumble on delivery, the consumer simply moves to the competitor.
Right.
So from a purely financial and management perspective, the only way to survive that kind of high-pressure environment is to reach a state of absolute operational excellence, where timelines are compressed and waste is just zero.
But the authors point out something really fascinating about why so few businesses actually achieve this.
Yeah, 4 disciplines.
Right. They introduce this concept of the 4 antagonistic disciplines.
Ah.
It suggests that the very structure of a modern company is constantly pulling itself apart.
It's a critical concept to grasp because, well, it explains the friction you feel in your daily work.
Mm-hmm.
Let's look at the company as a system of 4 distinct competing forces.
Okay, what's the first one?
First, you have finance. Finance wants low costs, strict budgets, high margins, and predictability.
Right. They want to save money.
Exactly. Then you have the people dimension, or human resources. Their mandate is high employee retention, psychological safety, motivation, and personal development.
So right out of the gate, those two are colliding. Finance wants to freeze the training budget to hit a quarterly number, and HR is saying that freezing the training budget will cause our best talent to walk out the door.
That's the first collision, yeah. Now add the third force, industrial engineering.
Okay.
This group is hyper-focused on efficiency, standardized processes, lean performance, and absolute consistency. They want the production line to run like a metronome.
Got it. And the fourth?
Finally, the fourth force is technology and R&D. Technology wants cutting-edge, disruptive innovation. They want to change the materials, add new features, and release beta versions immediately.
Regardless of whether the manufacturing process is perfectly standardized yet.
Exactly. They don't care about the metronome.
Let's use an analogy here to make this concrete for everyone listening. It sounds like 4 different people trying to design the same car.
Oh, that's a good way to look at it.
Right. Like finance is screaming to build it out of cheap plastic to keep costs down. Engineering is demanding it be built like a tank so it never breaks down and standardizes the assembly. Technology wants to strap an experimental, untested jet engine to the roof. And HR is insisting that the seats be hand-stitched ergonomic leather so the driver feels valued.
That is exactly it.
How on earth do you build a functional car when the designers are fighting like that?
The harsh reality is most companies don't. They just let whichever department has the most political power at the time dictate the direction.
Oh, interesting.
Yeah, it creates a tremendous amount of bias. Managers lean toward whichever discipline they understand best. If your CEO came up through finance, the whole company slowly starves R&D to hit margin targets.
Makes sense.
But if the CEO came from engineering, you get incredibly robust products that cost way too much to make.
Which brings us back to that thought experiment we opened with. The company making record profits but bleeding talent.
Yes. In that scenario, finance is winning the tug of war and HR is losing. But is that operational excellence?
I'm guessing no.
No, because eventually the cost of recruiting and training new people every year will erode the profits, or the lack of experienced talent will lead to a catastrophic product failure.
Okay, what about the reverse? Let's say you have a company that has been bleeding cash for 5 years. They haven't turned a profit, but they hold the patents to an incredible bleeding edge technology. The tech press loves them. Is that excellence?
Again, no. In that scenario, technology is winning, but finance is losing.
Right.
If you cannot produce the technology at a cost the market will bear, you don't have a business, you have a very expensive research project.
That's a great way to put it.
The authors argue that true operational excellence means uniting all four of these dimensions, finance, people, engineering, and technology, into a single, lean, quality system. You have to advance all of them simultaneously.
Not sacrifice one for the other. Okay. Conceptually, that sounds great. But human beings are inherently resistant to change.
Oh, definitely.
If I'm an engineering manager, I don't want to compromise my robust processes just to appease finance or tech. Why is it so rare to get these four forces aligned?
It comes down to human paradigms. Psychology plays a massive role in operations. We have a fundamental biological rejection of change.
Like we just want things to stay the same.
Exactly. Managers will often prefer the predictability of their known, flawed routines over the uncertainty of a new, potentially better system. Yeah, even when financial results are dropping, even when the data shows the current method is failing, people will cling to their silos because it feels safe. The fear of disrupting the known routine overrides the logic of making unifying improvements.
It sounds like trying to conduct a symphony orchestra, but instead of sitting in a stable concert hall, the orchestra is on a raft riding turbulent rapids.
That is a terrifying image, but very accurate.
So how do we stabilize the raft before we can even think about playing the music? If I'm trying to align finance, engineering, HR, and tech, what is the unifying metric? What is the lighthouse?
The text provides a very clear, uncompromising answer to that. The only way to stabilize the raft, to stabilize the company, is by orienting every single person toward one metric,
Which is?
the gross margin.
Okay, let's unpack this mechanism. Why gross margin? Why not top-line revenue or customer satisfaction scores or net profit?
Because gross margin, or GM, is the ultimate financial indicator that ties the physical reality of operations directly to the business's viability.
Okay, explain that a bit more.
Well, gross margin is calculated by taking your total revenue and deducting the cost of goods sold, so the direct and indirect costs of actually making and delivering the product.
So it's the money left over after you've paid for the materials, the factory labor, and the shipping, but before you pay for the marketing team or the corporate headquarters.
Precisely. And here's the thing. Operations controls roughly 50% of a company's total revenue spending,
Half of it, wow.
right? Therefore, the operations department is almost entirely responsible for the gross margin line on the P&L. If gross margin is healthy, the company has the cash flow to invest in R&D, pay for HR initiatives, and satisfy finance.
So by focusing everyone on improving that one metric, you inherently align the antagonistic disciplines.
Exactly.
But here's the practical problem. If I'm a shift supervisor on a factory floor or an engineer calibrating a CNC machine, I do not speak the language of P&L statements or gross margin percentages.
No, of course not.
Right. If my manager comes to me and says, hey, we need a 2% bump in gross margin this quarter, my eyes are going to glaze over. That means nothing to my daily workflow.
And this is where most leadership completely fails. You are absolutely right. The production floor doesn't speak P&L.
Right.
The profound insight from the authors is that management must translate gross margin goals into the daily KPIs, the key performance indicators that specific departments actually control and understand.
You can't just command a financial outcome.
Exactly. You have to translate it into an operational behavior.
So how does that translation actually work? What is the math behind it?
Let's break it down. If finance dictates that the company needs to improve gross margin by reducing the cost of goods, the operations director has to look at the components of those costs.
Okay.
For the manufacturing team, you translate that financial goal into cycle time. You don't say improve the margin. You say, we currently take 40 days to build this product. Every day the product sits on the floor, it consumes overhead, electricity, labor, floor space.
Right, it's just eating money.
Exactly. So you tell them to hit our financial goal, we need to reduce cycle time from 40 days to 35 days.
That makes it tangible. The factory worker can actually visualize moving a product through the line 5 days faster. What about the engineering team?
For engineering, you translate gross margin into yield points.
Yield points. Okay, explain that.
Yield is the percentage of products that pass quality checks the first time without needing to be thrown away or reworked. So you tell the engineers, we need to increase the first pass yield from 85% to 88%. Again, the financial math happens in the background. An 88% yield means fewer scrap materials, which lowers the cost of goods, which raises the gross margin.
But the engineer is entirely focused on the technical challenge of improving the machine's precision, which is what they are trained to do.
You got it. You are translating the what's into the how for each specific discipline.
Okay, so let's look at the bricks that build this foundation. You mentioned the cost of goods, the COGS. The book goes into detail on how to aggressively attack these costs.
It does.
Let's start with the literal materials, the bill of materials, or BOM. If I manufacture a piece of medical equipment and it has 10,000 individual parts on the BOM, how do I reduce that cost without driving my procurement team insane trying to negotiate 10,000 different contracts?
You don't negotiate 10,000 contracts. That is a recipe for organizational paralysis.
Yeah, that sounds like a nightmare.
The rule here is strict adherence to the Pareto principle, also known as the 80-20 rule. You run a data analysis on your BOM, and you will inevitably find that roughly 20% of the parts drive 80% of the total material cost.
So you just ignore the rest.
You ignore the cheap plastic washers and the standard screws. You focus relentlessly on the top 20% most expensive items, the custom microchips, the specialized sensors, the high-grade alloys.
So you identify the big-ticket items.
Yeah.
Then what? Do you just call those suppliers and demand a 10% discount?
No, definitely not, because that destroys the relationship and makes your supply chain incredibly fragile. The text emphasizes building long-term win-win relationships with those specific top-tier suppliers.
So how do you do that without just squeezing them?
You don't just squeeze them for pennies. You go to them and say, how can we change our design to make this easier for you to manufacture? Or, if we guarantee a 3-year contract, can you lock in the raw material price to buffer us both against global price spikes?
Oh, so you build a strategic partnership.
Exactly. If you just squeeze them, the moment there is a global shortage, they will prioritize their other customers and your factory will stop.
Okay, so we've Pareto optimized the materials. What about labor? This is the one that usually makes people nervous. How do you reduce labor costs effectively without just laying people off?
You reduce labor costs through aggressive cycle time reduction campaigns. And the results detailed in the book are staggering. They provide an illustrative case study of a company assembling complex machinery.
Okay.
Through structured methodology, they dropped the assembly and integration cycle time from 121 days down to 31 days.
Wait, I have to push back on that. From 121 days to 31 days, that is cutting 90 days out of a manufacturing
That
process.
sounds impossible, I know.
In the real world, you don't cut 75% of your time without seriously compromising quality, skipping safety checks, or forcing your workers to work dangerous amounts of overtime. How is that physically possible?
It's possible because of a fundamental misunderstanding of what cycle time actually is. When you hear 121 days, you assume workers are physically turning wrenches on that machine for 121 days.
Right, that's what I picture.
They aren't. In a non-optimized system, the vast majority of cycle time is just waiting. It's empty space.
Waiting for what?
Waiting for parts to arrive from the warehouse, waiting for an inspector to sign off on a quality document, waiting for a test bay to open up, waiting for engineering to clarify a confusing schematic.
Oh, wow.
The actual touch time, where a value is being added, might only be 20 days. The other 101 days are purely administrative and logistical friction.
Ah, I see. So how did they remove that friction?
They achieved it within 4 consecutive quarters through structured joint work. They put the technicians, the engineers, the purchasing managers, and the planners in the same room. They mapped every single step of the 121-day process and identified the non-value added waiting times.
Okay, give me an example of what they changed.
Well, if a machine sat for 3 days waiting for a QA signature, they moved the QA inspector's desk to the assembly line. They didn't make the workers swing hammers faster. They removed the empty space between the hammer swings.
That makes so much more sense. You are optimizing the flow, not accelerating the physical human labor.
Exactly.
Now let's talk about the trickiest part of COGS. Manufacturing overhead, or MOH. This is the indirect cost, the supervisors, the reporting, the facility maintenance. When corporate says, we need to cut overhead, the immediate assumption is we are doing mass layoffs.
And the authors warn that you must handle overhead reduction with extreme care. Cutting overhead blindly with a top-down mandate destroys team trust. It completely ruins the people dimension of our 4 operational disciplines.
Right. HR would lose their minds.
Exactly. If people feel like their jobs are constantly under threat, they will stop sharing ideas, they will hide mistakes, and innovation will just die.
So how do you reduce overhead without creating an atmosphere of terror?
You use a collaborative tool called a start, stop, and continue session. Instead of an executive bringing in an axe, you sit down with the actual teams and facilitate a joint thinking session. You ask them to categorize every task they do.
Give me a hypothetical scenario of how this actually plays out in a meeting.
Let's say you have an administrative team in operations. You ask them, what activities are critical and must continue? They might say, the weekly safety audit.
Great.
What activities are missing and need to start? They might say, we need a daily 5-minute alignment with procurement. Excellent. Then you ask the hardest question. What activities are no longer adding value and need to stop?
Do people actually volunteer to stop doing their own work? I mean, really?
They do, if they feel safe. For example, a team member might say, every Friday I spend 4 hours compiling a massive spreadsheet on machine utilization. I sent it to 7 managers. I don't think anyone has actually opened that email since 2022.
Oh man, that happens all the time.
Right. You investigate, realize the managers now get that data automatically from a new software dashboard, and you instantly eliminate 4 hours of overhead a week. You do that organically with the team's buy-in. It exposes redundancies without fear.
That's a really great mechanism. So we've tackled materials, labor time, and overhead. Let's go back to the engineers. You mentioned earlier that translating gross margin for them means focusing on yield. Why is yield so critical?
Yield improvement is perhaps the purest form of net saving, because every single dollar saved flows directly to the bottom line. If your yield is 80%, it means 20% of everything you build goes straight into the dumpster, along with the labor, materials, and overhead it took to build it.
Ouch.
The text outlines 3 distinct phases of yield improvement that an engineering team goes through.
Walk us through the phases. What's the reality of pushing that number up?
Phase 1 is the most dramatic. This is where you see massive jumps, say, moving from a 45% yield to a 68% yield in a matter of weeks. You achieve this by fixing the major glaring offenders.
Like what?
Like a tool is calibrated completely wrong, or a specific part is repeatedly failing under stress. They're easy to spot and highly impactful to fix.
Then you hit phase 2.
Right. Phase 2 is the slow climb. You're moving from, say, 70% to 85%. The obvious problems are gone. Now you are hunting for root causes. Maybe a machine only fails when the humidity in the factory rises above a certain level.
Oh, so it's much harder to track down.
Exactly. Finding that takes data analysis, and the gains are only a few percentage points at a time.
And phase 3.
Phase 3 is grueling. This is the fight for incremental sub-1% gains to push a yield from 95% to 98%. You are dealing with microscopic variables in materials or tiny fluctuations in electrical currents.
So going from 97% to 98% might take more engineering hours than jumping from 45% to 68%?
Absolutely. But here's the crucial financial insight from the authors regarding yield. Doing the heavy lifting of phase 1 early, during the low-volume ramp-up of a new product, is hyper-cost-effective.
Wait, why does the timing matter so much?
Because of the volume of material. Imagine you are ramping up a new product. In month 1, you only produce 100 units a day. If your yield is 50%, you are scrapping 50 units a day.
Right.
It hurts, but it's manageable. That is when you want your engineers working around the clock to fix those phase 1 issues. If you ignore them and wait until month 6 when full production is pumping out 10,000 units a day.
Oh, I see. A 50% yield means you're throwing 5,000 units a day into the garbage. The financial burden of the scrap material would obliterate your gross margin.
Exactly. You have to solve the big yield problems when the flow is slow.
Okay, I need to take a step back and look at this whole picture.
Sure.
We are ruthlessly compressing cycle times, stripping out empty waiting periods. We are holding start, stop, continue sessions to eliminate non-value-added overhead. We are optimizing yield to near perfection. A skeptic listening to this is going to say, this is just a sophisticated way to justify mass layoffs. Like, if we need less time and less overhead to do the same amount of work, we are going to fire half the floor. Is lean operations just a euphemism for downsizing?
It is the most persistent and damaging misconception about lean methodology, and the authors go to great lengths to address it. Lean is not about slashing headcount. It is fundamentally about leveraging your existing capacity to absorb growth.
Explain how that works in reality. If I have 100 people and they become twice as efficient, I only need 50 people, right?
That assumes your company's revenue and output are entirely static, which is rarely the case if you are improving operations. The book provides an incredibly illustrative chart to prove this point. It maps a real company's product ramp, their production volume, over a period of years. The volume of product shipped increases by 4 times. It quadruples.
Okay, so output goes up 4x. What happened to the headcount?
The line, representing the number of engineers and operators, stays exactly flat.
Wait, really? They quadrupled production without hiring anyone? Did they force everyone to work 80-hour weeks?
No. They achieved it through process stabilization, removing the non-value-added tasks we talked about, and introducing targeted automation. The existing team just became radically more effective.
Ah,
When you remove the waste, the waiting, the redundant reporting, the rework from bad yields, that team of 100 people can suddenly produce 400 units instead of 100 units in the exact same 40-hour work week. You don't fire 50 people, you use the whole team to dominate the market with a massive increase in output at the same fixed labor cost. That is how gross margin explodes.
okay. That paints a very different picture. It's about building a scalable engine, not just a smaller engine.
Exactly.
But let's shift gears from the theory to the daily reality. If you're an operations manager, your hair is on fire every single day. A supplier is late, a machine just broke down, the CEO is asking for an update on a new product. If this lean methodology is the goal, how do we actually implement it? Because you can't just pause the factory for a month to send everyone to a lean seminar.
No, you can't. And trying to implement massive disruptive changes all at once usually triggers the organization's immune system, and the changes are rejected. The authors argue that the only way to successfully implement this in the real world is through a methodology they call small steps.
Small steps. How small are we talking?
To understand the methodology, you first have to understand the daily chaos of manufacturing. The floor is dominated by urgent tasks that demand immediate attention. You have AOS, Assurance of Supply.
What's that?
That is the daily grind of making sure the current customer gets exactly what they ordered today. It's putting out today's fires. Then you have NPI, New Product Introductions. These are the prototypes for next year's products. They're highly visible to executives, highly stressful, and constantly running into technical roadblocks.
Right. So you have today's crisis and tomorrow's deadline constantly fighting for the same resources. In that environment, how do you focus on important but non-urgent tasks? Things like safety audits, cross-training employees, or doing a deep dive data analysis on yield.
That's the challenge.
Right. The urgent will always crowd out the important.
That is the crux of the problem. The small steps methodology tackles this in two ways. Step one is uniting activities. You have to stop siloing the work and start deliberately sharing resources between the urgent and the important.
Give me a concrete example of uniting activity.
Let's say you have an urgent AOS issue. A current product needs a physical stress test because a batch of metal looks suspicious. You also have an NPI issue. A prototype for next year needs a similar stress test.
Okay.
In a normal factory, those are two different departments fighting to book time on the same testing machine. Uniting activities means management steps in and designs a protocol where both the AOS part and the NPI prototype are loaded into the machine and tested simultaneously by the same engineer. You blend the workflows to eliminate the queue time.
So you're forcing collaboration to free up machine time. That makes sense, but it requires a lot of foresight. What is the second part of the methodology?
Step two is the actual small steps practice. The rule is that you invest just 15 to 30 minutes a day on the important, non-urgent improvements. That is it. You don't ask for a 4-hour block. You ask for 15 minutes.
I mean, 15 minutes sounds almost too small to matter. What can you realistically fix in 15 minutes?
It's not about what you fix in one day, it's about the compounding effect of consistency. The text gives several practical examples of what this looks like. It might be a manager spending exactly 10 minutes a week doing safety management by walking around.
It's just walking the floor.
Yeah, just walking the floor, the full intention of observing safety protocols, not checking production numbers. Or it might be a 15-minute stand-up meeting right next to a machine to review a specific quality failure from the day before so the lesson is learned instantly.
That's very doable.
Exactly. Or it would be dedicating 30 minutes once a month to sit down with a technician purely to discuss their personal career development.
So instead of trying to schedule a massive, disruptive 3-day offsite training retreat, which everyone hates and immediately forgets anyway, you just drip feed the cultural and operational improvements into the daily rhythm.
Exactly. The 15-minute window is so small that no one can argue they don't have time for it. It bypasses the organization's resistance to change. And over a year, those tiny daily investments compound into massive cultural shifts and process improvements.
That's powerful.
But to ensure those small steps are actually moving the company in the right direction, the operations team needs a guiding framework. The authors rely heavily on lean thinking, and specifically a concept called the theory of constraints, or TOC.
The theory of constraints. This is a famous concept in operations, but a lot of people misunderstand it. How does the book define the actual mechanism of TOC?
The core premise of the theory of constraints is that every complex system, whether it's a factory, a hospital, or an IT network, is prevented from achieving more of its goal by at least one bottleneck or constraint. The entire focus of management must be on identifying and managing that single constraint, because improving any other part of the system is essentially an illusion.
Let's walk through an example to make that clear.
The text uses a great, simple, illustrative model. Imagine a production line with 3 sequential steps. Step 1 is cutting raw steel, and it can process 1,000 units a week. Step 2 is a highly specialized CNC machining process, and it can only process 650 units a week. Step 3 is final assembly, and it can handle 800 units a week.
Okay, the math is straightforward. Step 2 is the bottleneck. It's the constraint. No matter how hard the rest of the factory works, the company can never produce more than 650 units a week.
Correct. So TOC introduces a management mechanism called drum buffer rope to optimize this reality.
Let's break this down. What is the drum?
The constraint itself, step 2, is the drum. It dictates the drum beat, or the maximum rhythm, for the entire factory. Management has to accept that 650 units is the heartbeat of the business.
What about the buffer?
The buffer is a deliberate stockpile of inventory placed immediately before the constraint. Think about it. If step 1, the skill cutter, breaks down for 3 hours, what happens to step 2?
If there's no inventory waiting, step 2 runs out of steel and has to stop working.
And if the constraint stops working, the entire factory is permanently losing time and money it can never get back. An hour lost at step 1 doesn't matter because it has excess capacity. An hour lost at step 2 reduces the company's total revenue.
I see.
So you place a buffer of work-in-progress inventory right in front of step 2 to ensure it is never starved for materials, even if the upstream machines temporarily fail.
It's an insurance policy for the bottleneck and the rope.
The rope is the crucial communication mechanism. It ties the release of raw materials at the very beginning of the line to the exact pace of the constraint. If step 1 can cut 1,000 units, the natural instinct of the step 1 manager is to run their machine at maximum efficiency and produce 1,000 units.
But if they do that, and step 2 can only process 650,
You end up with 350 units of partially finished steel piling up on the factory floor every single week.
which is a disaster. That piled up inventory ties up the company's cash, takes up physical warehouse space, and if there's a microscopic defect in the steel, you won't discover it until step 2 processes it weeks later, meaning you have to scrap thousands of parts.
Exactly. The rope prevents that overproduction. The rope sends a signal to step 1 that says, only release 650 units worth of raw steel into the system this week. Do not produce more.
I love this concept. Let's apply an analogy to solidify it. It's exactly like managing a highway system. Imagine you have a 5-lane highway, that's step 1. But
Yeah.
5 miles down the road, it funnels into a 2-lane toll booth.
Right.
The toll booth is your constraint. It's the drum. It dictates exactly how many cars can pass per hour. If you just let cars flood onto the 5-lane highway at maximum capacity, what happens? You don't get more throughput. You just get a massive gridlocked traffic jam. That traffic jam is your wasted inventory.
Yep, perfect analogy.
The buffer is making sure there are always a few cars ready at the toll booth so the attendant is never waiting. And the rope. The rope is the stoplight at the highway on-ramp. It only turns green and lets a new car onto the highway when a car exits through the toll booth.
That is a phenomenal visualization of the concept. The toll booth dictates the entire system. And what's fascinating is that the authors don't just apply these lean tools to the physical factory floor. They apply the exact same logic to the administrative side of the business.
Really?
Yes, specifically to how we handle information constraints, like emails and meetings.
Oh, please tell me there is a lean methodology for surviving my inbox. Because for most managers, email is the ultimate traffic jam.
There is. The text applies the Covey matrix, which evaluates tasks on a grid of urgency versus importance directly to email management. Most people are completely reactive to their inbox. They answer whatever is screaming the loudest, the high urgency item. But the secret to operational excellence isn't answering every fire drill email instantly. It is focusing almost exclusively on the high importance, low urgency emails.
Wait, that feels counterintuitive. If an email is high importance and high urgency, like a major customer demanding an update, shouldn't that be the priority?
You have to put out the active fires, yes. But if you spend your entire day fighting fires, you will never improve the system. The high-importance, low-urgency emails are what the authors call weak signals. They are the early warning signs of systemic deviations.
Give me an example of a weak signal.
It's an email buried in your inbox from a quality tech mentioning a slight statistical anomaly in a yield report from a sub-tier supplier. or a note that a machine took 5 minutes longer to calibrate than usual.
So no one is panicking yet.
Right. Nobody's screaming about it yet. It's low urgency. But it is high importance because if you ignore that slight deviation, next month that supplier is going to ship a batch of defective parts that halts your entire production line, creating a massive, all-hands-on-deck, high-urgency crisis. Dealing with the weak signals proactively is the only way to stop the fires from starting.
So if you ignore the low urgency stuff, it inevitably metastasizes into high urgency stuff. You're just delaying the crisis. What about meetings? If emails are the incoming raw material, meetings are the administrative bottleneck. How do we fix the endless cycle of useless meetings?
The rule presented in the text is harsh but absolutely necessary. An effective meeting must yield a measurable improvement in operational KPIs a month later. If it doesn't, the meeting was a waste of organizational resources.
That is a brutally high bar. How do you evaluate that in the moment?
The authors suggest a mental benchmark trick. Think back through your career to a specific breakthrough meeting, a session where a cross-functional team actually mapped a process, identified a root cause, and made a decision that permanently changed yield or significantly dropped costs.
Okay, I have one in mind.
Keep that memory clear. Whenever you sit in a new meeting, compare to that benchmark. Are we analyzing real data? Are we debating actionable changes? If the current meeting is just people reading status updates aloud that could have been in an email, it does not measure up. You are just manufacturing administrative inventory that serves no purpose.
Okay, so we've mapped out the physical constraints of the factory floor, we've stabilized the rhythm with drum buffer rope, and we've ruthlessly optimized our emails and meetings. The operation is stable.
Very stable.
But here is the ultimate challenge. A perfectly efficient machine only does what it is programmed to do. It just does it faster with less waste. If a company wants to adapt to a changing market, to grow aggressively, and to drastically improve those gross margins year over year, the operations team has to do something that is usually walled off in the R&D department. They have to innovate.
And this requires a massive paradigm shift for most business leaders. We have to completely demystify what innovation means in operations. We're culturally conditioned to think innovation is a lone genius in a lab coat inventing a new microchip. But operations innovation is entirely different, and mathematically it is far more lucrative.
More lucrative than inventing a new product. How does the math on that work?
It comes down to scale. Because the operations department controls the vast majority of a company's budget, the raw materials, the shipping, the real estate, the labor force, any percentage saved here is magnified across the entire balance sheet.
Ah, I see.
If R&D designs a new feature, it might increase sales by 5%. But if operations invents a new way to process materials that saves 1% of the cost, that 1% multiplied across the millions of units produced yields millions of dollars directly to the bottom line. The authors state that aggressive operational innovation can drop overall cost of goods by an incredible 20% to 50%.
A 50% reduction in COGS. That isn't just an efficiency gain, that completely alters the competitive landscape. If you can make your product for half the cost of your competitor, you can either crush them on retail price, or you can reinvest massive profits back into marketing and R&D.
Exactly.
But how do you actually execute that? You can't just mandate an operations manager to be innovative today.
No, you can't. Innovation is a process, not a command. And there's a very strict prerequisite before you even attempt it. You cannot innovate in chaos.
Okay, what does that mean?
If your factory floor is constantly putting out fires, if your yields are wildly fluctuating between 60% and 90% depending on the day, you're not ready for innovation. Any new idea you introduce will just add noise and risk to an already unstable system.
So you have to stabilize the raft before you start trying to upgrade the motor.
Exactly. Product quality and process robustness must be stable first. Once you have a baseline, the text insists on using a control change board, or CCB. Operations innovation relies entirely on data-driven statistical analysis.
So no guessing.
None. Before an engineer is allowed to change a material or alter a machine setting to see if it works better, they have to present statistical evidence to the CCB proving the change will not negatively impact the current stability. It is highly disciplined.
So it is the exact opposite of Silicon Valley's move fast and break things mantra. In operations, it's move methodically, prove the math, and optimize things.
Precisely. The text outlines 3 formal phases of operational innovation. Phase 1 is initiation. This is the searching phase, looking for new solutions, identifying pain points, and proposing ideas.
Okay, and phase 2?
Phase 2 is adoption. This is where you evaluate the idea against your specific environmental context and constraints. Will this new robotic arm actually fit in our facility? Does it integrate with our software?
Right. And phase 3.
Phase 3 is implementation. This is the heavy lifting of institutionalizing the idea into the daily routine and training the staff.
Phase 2 and 3 sound like standard project management. But phase 1, initiation, that requires a specific kind of creative culture. You need people who are willing to look at a machine that has worked perfectly for 5 years and ask, how do we make this 20% cheaper?
It's hard to do.
How does the book suggest fostering that culture? Because I can tell you, the book has a mandate for this that is highly controversial.
It is controversial, but it addresses the core obstacle to innovation. To foster phase 1 initiation, you must intentionally introduce diverse perspectives into your workforce. The actionable and highly debated step the authors mandate is this. A healthy operations organization must aggressively recruit 20% to 30% inexperienced engineers.
Okay, if I am the CFO and my lighthouse is gross margin and I know that mistakes cost us money, intentionally hiring 30% fresh out of college, inexperienced people sounds like an absolute recipe for disaster. That sounds like a guarantee of slowdowns, miscommunications, and scrapped material. How does an operations director possibly defend that risk to a board?
By explaining the classic efficiency versus resilience trade-off. If you only hire 20-year industry veterans, you buy immediate efficiency. They know exactly how the machines work, they know the suppliers, they require zero training.
Right, they just get to work.
But the hidden cost of a veteran-only workforce is a disease called paradigm paralysis.
Paradigm paralysis, meaning they are trapped by their own expertise.
Exactly. When you ask a veteran why a specific, costly testing protocol is done a certain way, their answer is usually, because that is how we have always done it, and it works. They will optimize the existing process, but they will never disrupt it because their identity and comfort are tied to that process.
Give me a real-world scenario of how an inexperienced engineer breaks that paralysis.
Imagine a team of veteran engineers who spend 4 hours every week manually calibrating a complex optical sensor. They've done it for 10 years. They are very fast at it.
Okay.
You hire a 22-year-old engineer fresh out of university. They watch this process and ask, why are you doing this by hand? In my coding class, we use a simple Python script and a $50 camera to automate this kind of calibration. Why don't we just write a script?
And the veterans never thought of it because Python wasn't standard when they learned the process. The new hire challenges the status quo simply because they don't know the status quo.
Exactly. As management, you intentionally absorb the short-term training costs and the initial friction, because that friction is the only thing that generates long-term disruptive ideas.
That makes total sense.
Those inexperienced engineers asking naive questions are the ones who will eventually provide the insight that allows you to automate a process and drop your COGS by that coveted 20% to 50%. You are not paying for their current efficiency, you are buying future resilience and innovation.
That is a massive perspective shift, but there is a huge caveat here. Asking why only works if the 22-year-old doesn't get yelled at by the veteran for asking. If the culture is toxic, that new engineer will learn to shut their mouth within a month, and you lose the innovation.
Which brings us to the concept of VOE, the voice of the employee. The absolute foundation of phase 1 innovation is psychological safety.
Meaning what, practically?
True innovation requires people to admit when a process is failing, to confess their own mistakes, and to suggest wild, unproven ideas without any fear of retribution or humiliation. If a technician figures out a slightly faster way to assemble a casing, but fears it will upset the senior engineer who designed the original process, that innovation dies in silence.
So how do you practically build that psychological safety? It is very easy for a CEO to put, "We value your ideas," on a poster in the break room. It is incredibly hard to make a line worker actually believe it.
Right.
What is the mechanism?
The actionable mechanism provided in the text is the rigorous use of anonymous organizational health surveys. But not just the generic HR surveys that ask you to rate the cafeteria food on a scale of 1 to 5.
Right.
To foster operational innovation, the survey must include 2 very specific open-ended questions. Question 1, what are our points of strength? Question 2, name 2 areas requiring improvement.
Why those specific questions?
Because it forces reflection on the actual system. And the anonymity provides a fertile, genuinely safe ground for employees to point out systemic flaws or management blind spots that executives are entirely unaware of.
Okay.
When leadership takes those anonymous suggestions, reads them publicly, and actually implements a change based on them without witch hunting the author, you prove that the psychological safety is real.
It's fascinating. We've spent this time covering the hard metrics, the gross margins, the cycle times, the drum buffer rope constraints. But this reliance on psychological safety, on intentionally hiring fresh perspectives, on anonymous feedback, it brings us to the ultimate, inescapable foundation of operational excellence.
Yeah, what's that?
You can install a multi-million-dollar ERP system, you can map your processes perfectly, but the entire machine rests entirely on how you manage the human beings operating it.
Human beings are the glue that holds the system together, or the solvent that breaks it apart. The authors emphasize that leadership in modern operations isn't built on authority. It isn't about pulling rank or yelling louder than the next guy.
So what is it built on?
True operational leadership is built on consistently delivering added value results to your team and fundamentally buffering them from the unpredicted hits.
Let's focus on that phrase, buffering the unpredicted hits. What does that actually look like for a manager?
Manufacturing and supply chains are, by their very nature, statistical and full of variance. You can plan perfectly, but reality will always intervene. A machine will break down. A container ship will get delayed in a port. A power grid will fail. The unpredicted hits are inevitable.
So when the hit happens, what is the leader's job?
A poor leader panics, runs onto the floor, and starts screaming at the technicians to work faster to make up the lost time. They pass the chaos directly down to the front line.
I've seen that happen.
We all have. A true operations leader acts as a shock absorber. When the supply shock hits, the leader steps in, coordinates with procurement to find an alternate part, works with finance to authorize emergency overtime pay, and talks to sales to manage the customer's expectations.
So they take on the administrative burden.
They handle the organizational chaos so the technician on the floor can stay calmly focused on their specific task. You earn trust by protecting your team's ability to work.
You are buffering the constraint, just like the physical inventory buffers the CNC machine. But leadership isn't just about protecting the team, it's also about driving individual performance. How do you take these massive concepts, gross margin, yield, TOC, and make an individual engineer feel accountable for them?
That alignment happens in the one-on-one meeting. The text is definitive on this point. The one-on-one is where accountability lives. But most managers do it completely wrong. They treat it as a status update. They sit down and say, what are you working on this week? Are you going to hit the deadline?
Which is a waste of time, because a good manager should already know the status from their project dashboard.
Exactly. The one-on-one is not for project tracking. It is a tool for personal and professional development, using the SMOP model. The authors recommend structuring these interactions around specific, measurable operational progress, deeply aligning the individual's goals with the department's KPIs.
Okay.
But the core mandate is that the manager must prepare for this meeting meticulously.
What does meticulous preparation look like for a 30-minute one-on-one?
If you are managing a process engineer, you do not just show up with a cup of coffee and ask how they are doing. Before the meeting, you pull their specific yield data. You review the exact cost of goods implications of the project they are leading. You identify where their specific constraints are.
So you bring real data to the table.
You come into the room armed with objective data, and then, and this is the hardest part for many managers, you practice active listening.
You use the data as a foundation, not a weapon.
Yes. You say, I see the yield on the new casing drop 2% last week. Walk me through what you are seeing on the floor. What is the constraint you are running into, and how can I help remove it?
That's a huge shift in tone.
It is. You are actively developing their problem-solving skills using real operational metrics.
Yeah.
You treat human development with the exact same rigor and data-driven approach as machine maintenance.
And this collaborative, no-blame, data-driven culture cannot just stop at the loading dock of your factory. If you want true operational excellence, it has to extend outward to your supply chain.
Because your factory is just one step in a much larger macro system. If your internal team is perfectly lean, if your drumbeat is flawless, but your critical supplier is operating in total chaos, your system will eventually fail.
So how do you manage a supplier who is legally a separate company? You can't fire their employees.
The authors state you must treat suppliers with the strict no superiority and no inferiority attitude. You don't play the arrogant customer threatening to pull the contract every time they're a day late. And you don't act subservient to a massive global vendor. You treat them as an extension of your own factory. You create total transparency.
Transparency regarding what?
Financials, regarding operational KPIs and quality metrics. In a traditional adversarial relationship, a supplier builds a part, tests it, and ships it. When it arrives at your factory, because you don't trust them, your incoming quality team spends 3 days retesting the exact same part. That is duplicated effort. It's massive waste. If you build a transparent partnership, you align your testing protocols.
Mm.
You look at their yield data in real time. When you trust their data, you eliminate the incoming inspection entirely.
Wow, just skip it completely.
The part goes straight from the truck to the assembly line. You lean out the whole chain.
And the ultimate test of all of this, the supplier trust, the internal innovation, the yield optimization, the final judge of whether you have achieved operational excellence is the end customer.
Customer service is the ultimate unforgiving feedback loop. You can have all the green dashboards in the world, but if the product fails in the field, the system failed. When a customer reports a failure, it is not just a PR problem, it is a critical operational data point.
How does the book suggest handling a field failure?
The text prescribes an aggressive, immediate reaction using an emergency response team to execute what is called a closed-loop corrective action, or CLCA.
What is the timeline on a CLCA?
The benchmark expectation is to execute the corrective action within 12 to 24 hours.
Wait, within 12 to 24 hours of a customer calling in a broken product, you are expected to completely resolve the issue.
To execute the initial corrective action and contain the problem, yes. This requires an incredibly agile system. You immediately quarantine any suspect inventory in the warehouse, you trace the serial number back to the exact machine and operator that built it, you dispatch a replacement to the customer.
That is incredibly fast.
This immediate, overwhelming escalation does two things. First, it builds incredible brand loyalty. The customer sees you taking their issue instantly seriously.
And the second thing,
It feeds that failure data directly and immediately back into the NPI, the new product introduction process. The engineers designing next year's product need to know immediately that a specific plastic latch snapped in cold weather. The loop is closed. The field failure informs the future design, ensuring the next generation of products doesn't replicate the flaw. The system learns from its own failures.
taking a step back and looking at this entire conversation, there is a profound irony here.
What's that?
We started this deep dive talking about the rigid mechanics of business. We talked about cost of goods, gross margin percentages, bill of materials, and the math of cycle times. We mapped out the theory of constraints with toll booths and buffers. But the actual step-by-step manual to achieving this, when you really strip away the jargon, is almost entirely a masterclass in human psychology.
It truly is. The formulas and the lean tools are essential, but they are useless without the human element.
It's about having the empathy to build trust with suppliers so you don't waste time duplicating work. It's about cultivating the psychological safety necessary for a 22-year-old inexperienced engineer to look a 20-year veteran in the eye and say, your process is wasteful and I think I can fix it.
Right.
It's about a manager taking the time to actively listen in a one-on-one armed with hard yield data to help an employee grow rather than just demanding a status update.
The machines, the software, the metrics, they're just the tools. The people are the actual engine. Operational excellence isn't just a state of high efficiency. It is the difficult daily act of achieving harmony between finance, HR, engineering, and technology. And that harmony requires immense discipline, transparency, and a deep understanding of human behavior.
So to quickly recap the blueprint we've extracted today for anyone listening, if you want to transform your operations and build that unstoppable business engine, first, you must translate the CFO's high-level gross margin goals into the daily, tangible KPIs of the factory floor, like cycle time and yield.
Yeah.
Second, you must identify your system's bottleneck, your toll booth, your drumbeat, and protect it fiercely with inventory buffers. Third, you don't implement change with massive, terrifying disruptions. You do it through 15-minute daily small steps.
Crucial point.
Fourth, you must bravely hire inexperienced eyes to challenge your paradigm paralysis and drive innovation. And finally, you have to extend a culture of absolute trust, transparency, and rapid feedback to your suppliers and your customers.
And if we want to take these massive industrial concepts and connect them to the individual listener, it leaves us with a very provocative question to consider. Whether you manage a global supply chain or you are just trying to manage your own personal inbox and daily responsibilities, the fundamental mechanics of operational excellence apply to you.
How so?
Look at your own daily life as a production line. You have a steady stream of incoming raw materials like tasks, requests, chores, creative projects. What is your personal step two? What is your ultimate, unavoidable constraint that dictates the rhythm of your day? Is it your focus? Is it your energy level at 2:00 p.m.?
That's a great point.
Once you identify your personal toll booth, ask yourself, are you feeding that constraint with high-quality buckered preparation? Or are you just blindly letting tasks pile up in the form of wasted inventory, like unread emails, half-finished projects, and unnecessary meetings, until the system gridlocks?
That is a phenomenal lens to view your own work through. Identify your constraint and protect it. Because whether you are optimizing a billion-dollar manufacturing plant or just trying to get your own work done efficiently so you can go home on time, that X-ray machine of operational excellence works exactly the same way. It clears the murky waters and shows you exactly where the flow is broken. Thank you so much for joining us on this deep dive. Take these blueprints, find your constraint, and start optimizing your own world.